Hello everyone. In this session we have arc length in space. Definition: the length of smooth curve RT equal to xti plus ytj plus ztk, t between a and b inclusive, that is traced exactly once as t increases from t equal to a to t equal to b. It is L equal to integral from a to b of square root of derivative of x with respect to t squared plus derivative of y with respect to t squared plus derivative of z with respect to t squared dt. And here we have arc length formula. L, it is equal to integral from a to b of length of velocity vector v dt. So here again we have helix. We're gonna have this part when we working on examples of RT, it is equal to cosine Ti plus sine Tj plus Tk. So here example, the ladder is soaring upward along the helix RT equal to cosine Ti plus sine Tj plus Tk. How long is the ladder's path from time equal to 0 to time equal to 2 pi? So we're going to compute the arc length of this helix between 0 to 2 pi. So what we have for definition of arc length is here we have integral from 0 to 2 pi, absolute value of vector v dt, or in other words here we have integral from 0 to 2 pi, the length of velocity vector v dt. First we need to find velocity vector of the position vector, which means finding first derivative of r. So here we have r prime equal to, and this is equal to derivative of cosine. Here we have negative sine, derivative of first derivative of sine. Here we have cosine, and first derivative of t, it is 1. So here we have negative sine ti plus cosine tj plus k. And now finding length of v, which is equal to square root of sum of the squares of the components of the velocity vector. So here in this part we have square root of negative sine squared plus cosine squared plus 1 squared. And rewriting that part, so that is equal to here negative sine squared. We have sine squared plus cosine squared plus 1 using Pythagorean theorem. Sine squared plus cosine squared is equal to 1. So here, this part, it is 1. So this is equal to 1 plus 1. Here we have square root of 2. Now find L, which is the integral from 0 to 2 pi of the length of the velocity vector v. So L is equal to integral from 0 to 2 pi of square root of 2 dt. So integrate square root of 2, and here is equal to square root of 2 t. This is from 0 to 2 pi, and that is equal to square root of 2 pi minus 0, and that is equal to 2 times square root of 2 times pi units of length. Arc length parameter with base point p t naught. So here on this part we have arc length in terms of outer variable s, and s of t is equal to integral from t naught to t of square root of x prime tau. So here we use outer variable, and that is tau. So here we have x prime tau squared plus y prime tau squared plus z prime tau squared d tau, and that is equal to integral from t naught to t length of v tau d tau. So here on this part we have this absolute value of v, that is length of velocity vector with respect to tau. Compute the arc length parameterization of the curve RT equal to cosine Ti plus sine Tj plus Tk with initial point T naught equal to 0. So here our length st, it is equal to integral from t0 to t of length of velocity vector v tau d tau, and first we should find what we have for velocity, and that is equal to first derivative of r. So first derivative of cosine, first derivative of sine, and first derivative of t. So here we have, so our velocity vector has components negative sine t, cosine t, and 1. So length of velocity vector, it is equal to square root of negative sine squared plus cosine squared plus 1 squared, and that is equal to square root of sine squared plus cosine squared plus 1. Using Pythagorean theorem here, cosine squared plus sine squared, that is equal to 1. So this is equal to square root of 1 plus 1, and that is equal to square root of 2. Notice that the length of our velocity vector does not depend on the variable. Now we are going to write our parameterization s of t as the integral from t0 to t, and t0 is 0, so here we have from 0 to t of the length of the velocity vector v with respect to tau. Since there is no variable, we have a square root of 2 d tau. So we integrating constant with respect to tau. So this is equal to square root of 2 times tau, and this is from 0 to t. So this is equal to square root of 2 t minus 0, and this is equal to square root of 2 times t. So here we have s equal to square root of 2 times t, and t, it is equal to s over square root of 2. Now we can write our arcane parameterization with respect to s by substituting t here on this part. So we have out of t of s, it is equal to cosine. So here instead of t we have s over square root of 2 sine. Here again t, it is s over square root of 2, and finally on this part we have t, and that is s over square root of 2. Now here again on this part we have speed, and the fundamental theorem of calculus tells us that s is differentiable function of t with derivative of s with respect to t, and that is equal to length of a velocity vector v of t. So here we have unit tangent vector. We find the unit tangent vector t by dividing v by its length. So here we have t equal to v over length of v. Example, find the unit tangent vector of the curve r of t equal to 1 plus 3 cosine t I plus 3 sine t j plus t squared k. So first we should find velocity vector v, that is equal to first derivative of r with respect to t. So this is equal to negative 3 sine t I plus 3 cosine t j plus 2 t k. And next step, finding length of velocity vector v, and that is equal to the square root of negative 3 sine t squared plus 3 cosine t squared plus 2t squared, and this is equal to square root of 9 sine squared t plus 9 cosine squared t plus 4 t squared. And we can factor this part. We have 9 times sine squared t plus cosine squared t plus 4t squared. And now use Pythagorean theorem. Here we have sine squared plus cosine squared, so that part is equal to 1. So this is equal to square root of 9 times 1, that is 9 plus 4t squared. Now over unit tangent vector t, it is equal to velocity vector v over length of velocity vector v, and this is equal to negative 3 sine t over square root of 9 plus 4t squared I plus 3 cosine t over square root of 9 plus 4t squared j plus 2t over square root of 9 plus 4t squared times k. Find the curve's unit tangent vector. Also find length of the indicated portion of the curve. R of t is equal to 11 cosine cube t j plus 11 sine cube t k. T is between 0 and pi over 2 inclusive. So first step is finding velocity vector v. It is first derivative plot with respect to t, and that is equal to negative 33 cosine squared t sine t times j plus 33 sine squared t cosine t times k. And now finding length of velocity vector v, which is equal to negative 33 cosine squared t sine t squared plus 33 sine squared t cosine t squared, which is equal to square root of, here we have negative 33 squared, that is 1089, multiplied by cosine to the fourth power t, multiplied by sine squared t, plus, again here we have 1089, then multiplied by sine to the fourth power t, multiplied by cosine squared t. Use Pythagorean theorem, sine squared plus cosine squared equal to 1, and the fact that cosine t is greater than equal to 0 and sine t it is greater than equal to 0 for t between 0 pi over 2 inclusive. So here we have square root of 1089 times cosine squared t times sine squared t multiplied by cosine squared t plus sine squared t. So here on this part what they did, finding common factor here on this part and on this part, what we have in common was cosine squared t and sine squared t. And this is equal to square root of 1089 cosine squared t sine squared t, and here cosine squared t plus sine squared t is equal to 1. So what we have for length of velocity vector v, it is equal to 33 times cosine t times sine t. And now finding unit tangent vector, this is equal to v over length of v, so that is equal to negative 33 cosine square t sine t over 33 cosine t sine t times j plus 33 sine square t cosine t over 33 cosine t sine t times k. Simplify, and here we have negative cosine t times j plus sine t times k. And now find length of smooth curve defined by r of t. So here we have n equal to integral from 0 to pi over 2 of length of velocity vector v of t times dt. So this is equal to integral 0 to pi over 2. And here for length of velocity vector we have 33 cosine t sine t. So integrate, and this is equal to 33 over 2 sine squared t. This is from 0 to pi over 2. And this is equal to 33 over 2 sine squared pi over 2 minus 33 over 2 sine squared 0, and that is equal to 33 over 2. Here we have pi over 2 and sine squared pi over 2 is equal to 1. and here on this part we have 0. So our answer is 33 over 2. So what we have for t, the unit tangent vector of rt is negative cosine t times j plus sine t times k. And here L, or length of rt, it is equal to 33 over 2.